Good morning, class. Today we are going to talk about the prime numbers. Prime numbers are numbers that have only two factors, and these factors are supposed to be only one and the number itself. So when we talk about the prime numbers, we can start from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we would want to find out whether these numbers are prime numbers. For example, what are the factors of 1? The factors of 1, for sure, it is just 1, 1, and 1. So if it is 1 and 1, and you're saying that our prime factor is 1, a number that has only two factors, that is 1 and itself, then here we have 1. So we don't have two factors because this is just 1. Then if you go to 2, it has how many factors? It has only 1 and 2. So is 2 a prime factor? Let's see and check by using the facts that we are supposed to follow. A prime number should only have two factors, that is 1 and itself. That is 1 and the number itself, meaning that 2 is a prime factor. What about is a prime number? What about 3? How many factors does it have? It was only 1 and 3. Meaning that this 3 is a prime number. Why? Because it has two factors, that is 1 and itself, which is 3. What about 4? 4 has 1 and the 4. And also, when you multiply 2 by 2, then you'll get factor 2, because you cannot take the two of them. Then it means that this number has 3 factors, meaning this 4 cannot be a prime number because it has 3, not 1 and itself. What about 5? It has 1 and 5, so meaning it is a prime number because it has 1 and itself. What about 6? 6 has 1 and 6, and also when I multiply 2 and 3, I get 6. So 6 has 4 prime numbers, factors, so 6 cannot be a prime number. What about a 9? For example, it has 1 and itself, because every number has two prime numbers, that is the first one being 1 and itself, and then we have 3 times 3, which should take us just a 3, such that you will say that 9 has 3 factors, meaning that 9 is not a prime factor, a prime number. So it means then that if I'm supposed to get the prime numbers less than 100, then I'll go testing all the numbers and find out the ones with only 2 factors. For example, in our case from 1 to 10, because here we'll only have 1 and 7, here we'll have 1 and 8, and 2 and 4. Then here we'll have 1 and 10, and 2 and 5, meaning here they are 4, here they are 4, here they are 2. So if I was to check and find out from 1 to 10 how many numbers are prime factors, I'll have 2, and then I'll have 3. I cannot take 4 because it has 3 factors. Then I'll have 5 because it's 1 and itself. 6 cannot be because it has 4. 7 has 2 and 1 and itself, so 7 will be a prime number. 8 has 4 prime factors, so it 4 factors, so 8 cannot be a prime factor, a prime number. 9 has 3, so this cannot be a prime number. 10 has 1, 2, 5, and 10, so it has 4. Meaning that between 0 and 10, we have 2, 3, 5, and 7. Now, if you continue up to 99, you realize that between 0 and 10, we have 4 factors. And then between 11 and 10 and 20, we have another 4. Then between 20 to 30, we have 2. And here they're supposed to be the way I've listed them. Here they'll be 11, 13, 15 cannot, because 15 has 1 and itself, and then 3 and 5. You can see there are 4. So 15 cannot, as much as it looks like an odd number, a prime number. Then you have 17 and you have 19. You can see there are 4. Between 20 and 23 and 30, we'll have 2, which is 21, 23, because 21 has 4 factors. 22 has also 4, because this will be 1 and 21, and 22 and 2 and 11, and so the 4. So between then 30 and 40, if I continue, I'll have another 2. So if I continue like this, or if we continue like this, you'll find out what are prime numbers. Remember that I've just said that prime numbers are those that have only that 1 and the number itself to be the factor. So the factors should only be 2. Now, when we have done the prime factors, then the prime numbers, then this will help us to get the prime factors of any number. What do you mean by factors? In class 4, we said that multiples is equals to factors times factor. Meaning, if I multiplied 2 times 5, I'll get 10. So, for me to get the factors of 10, and especially the ones we are calling the prime numbers, prime factors, this will mean that I'll be looking for numbers that can be multiplied to get that number, but are in prime form. That is, the number you're going to get will only have 2 factors. That is 1 and 2. This one will be 1 and 5. So when I do the prime factors, I'll use the factorization method, which will be, for example, if I'm to get the prime factors of, for example, 16, then I'll make what we call a factor tree, which will be by dividing the 16, first of all, by the smallest prime factor, which we said is 2. And remember that 2, it is the only factor that is an even number. So we'll have 2. So if I ask myself, is 16 divisible by 2? For sure it is, because it is ending with a 6. So if I divide by 2, I know for sure I'll get an 8. Then I also divide again. I check whether I can still divide this number by 2. And it is true, I can, to get 4. Then I also divide this by 2 again, and I'll get 2. So in other words, I've gotten a 2, which is a prime number, another 2, another 2, another 2. Now these are 2 times 2 times 2 times 2 are the prime factors of 16. Now, you cannot get a prime number of this nature, like now 2 and 8. I cannot say that 2 and 8 are the prime factors of 16. Why? Because 8 is not a prime factor. That's why you have to go to the final prime factor.